we're going to build upon what you already know. So we're going to build upon the skills that you showed in your previous assessment. And so it says to evaluate the 3 primary trig functions. That's going to be the sine of an angle, the cosine, and the tangent. So I will not be asking for the reciprocals, cosecant, secant, and cotangent today. So here's our very first example. Now they're going to give us 2 true statements. And from those 2 true statements, we need to decide which quadrant is this terminal angle lying in. So I'm going to start by reminding us, when we say all-star trig class, we are telling ourselves, where do I find positive? So everything is positive in quadrant 1, only the sines and its reciprocal in quadrant 2, tangents and reciprocal in quadrant 3, and cosine and its reciprocal in quadrant 4. But remember, today we're only looking at these 3, sine, cosine, and tangent, the primary ones. Okay, so I'm going to get started. Is everybody ready? So I want to figure this out. I have a value for sine that's positive. Underneath that, I want you to write positive. So the first thing that I know is I'm given a fact that the sines are positive. So I come over here, and I'm just going to lightly shade in where a sine's positive. So all things are positive. That means sine would have to be positive, and here the sines are positive. So there's my first fact. How did I do that? I was given a value for sine. It doesn't matter what the number is. I'm just checking is it positive or negative to begin with. If it was negative, I would have shaded below. This second statement says the cosine value is greater than 0. That means the cosine values are positive. So now I'm going to go back to the same graph, and I'm going to shade where a cosine's positive. Well, all things are positive here, and cosines are positive down here. In only one quadrant will there be layered or a double shade. And that double shade tells us where we're going to graph this. So I'm going to make myself a new graph. I'm going to go somewhere into this quadrant. I choose to do it somewhere in the middle. And now I'm going to draw this terminal angle. I'm going straight out to that point and always back to the x-axis. The angle closest to the origin is the angle that I'm going to evaluate. Bless you. Let's do a quick review. I would like you to write this down. Sine is, okay, and I'm going to write cosine, and I'm going to write tangent. And I'm going to use that acronym, Oscar had a heap of apples. Oscar had a heap of apples. What is that doing as a reminder? That tells me when I am going to evaluate the sine of an angle, it's just the ratio of what is opposite of the angle over the hypotenuse. Cosine of the angle is what is adjacent to the angle over hypotenuse, and so on. All right, let's get started. So we can see that the sine is these 2 numbers. How can that help us with this triangle? Well, sine means opposites on top, so I'm going to put an O here, and hypotenuse is on the bottom. Remember, hypotenuse is always going to be the diagonal. So here on the diagonal, I'm putting the value 5. Your adjacent side is always going to be with the x-axis. So I know, by the way, this is adjacent, this is hypotenuse, and that makes this opposite. Opposite is the value 4. How am I going to find this missing side? So I know 2 of the 3 sides of a triangle. Remember, I asked you to have a calculator when you walked in, so please grab one if you haven't. And now I'm going to do the Pythagorean theorem. A squared plus b squared equals c squared. Now your a and your b are either leg. So I know one leg is 4. I don't know the second leg. That's what I'm trying to figure out. And I know the diagonal is the hypotenuse. 4 squared is 16. 5 squared is 25. And to isolate the b, I'm so sorry. To isolate the b, I'm going to subtract 16 from both sides. And I'm going to give students that are watching this video a chance to catch up here. Now, we don't just stop at 9. This isn't a length of 9. We need to isolate the b by taking the square root. And because we're talking about length, it won't be positive and negative, only positive. This is a length of 3. I'm going to let everybody get caught up. The directions for this were to find the sine, the cosine, the tangent. So I'm going to write that off. Sine, cosine, and tangent. Now I happen to be lucky. It already tells me that the sign is a positive 4/5. Easy enough. The cosine, well, cosine means adjacent over hypotenuse. As a quick reminder, cosine is adjacent over hypotenuse. So I come back here. Adjacent is 3, hypotenuse is 5. So this is 3 over 5. Tangent up above, we can see tangent is opposite over adjacent. Okay, opposite over adjacent, let me move this. Opposite is 4, adjacent is 3. Now in quadrant 1, all things are positive, so each one of these has a positive mark. Let's write down example number 2. It may seem intimidating, we have really large numbers here, but remember we have a calculator to use. So I'm going to start with, let's go over some facts. We know that we have a cosine that's negative, so I'm going to write that down. We have a cosine that's negative, and this means the tangent of the angle has to be greater than 0. If something is greater than 0, it's going to be positive. Okay, so I'm going to start by doing the following. I'm going to remind myself, all-star trig class, and I'm going to make a simple Cartesian plane where I'm just going to shade in the facts that I know. So the first fact is the cosine values are negative. Okay, this tells me where things are positive. So all things are positive here, and cosine is positive here. But I'm not looking for positives. The fact that I'm given is that the cosine is negative. So if they're positive here and the cosines are positive here, I'm going to shade quadrant 2, and I'm going to shade in quadrant 3. The next fact says, and this is harder, the tangent of the angle is greater than 0, which means it's positive. So I'm going to come back here. All things are positive here, and tangent is positive here. So if these are positive, and I want to know where is it positive, I'm going to shade here, and I'm going to shade here. And only one of the 4 quadrants will have an overlap or double shading. Wherever that double shading is, I'm going to go to that quadrant. I'm going to go right back to the origin. And now we always go to the x-axis. That angle closest to the origin is the angle that I'm going to evaluate. Let's remind ourselves, what does cosine even mean? Well, cosine is adjacent over hypotenuse. So over here, I'm going to remind myself, adjacent over hypotenuse. And then I think the number one reason why students sometimes get confused here is they're like, okay, I know the hypotenuse is the diagonal. That's always true. But I get confused. Where is opposite? What is adjacent? Well, for these problems, remember your adjacent side is always on the x-axis. So I'm going to put this as adjacent, and then opposite of the angle we're evaluating is straight across. All right, so let's do this. Cosine is 39 over 89. And you're like, what do I do with this negative? Remember, these are lengths of a triangle, 2 sides of a triangle, and lengths can never be negative. This just told us to go to the left. So forget about the negative for right now. Okay, adjacent of this angle has to be 39, and hypotenuse has to be 89. And now it's time to find this missing leg, which is right over here. So a squared plus b squared equals c squared. All right, this is a leg, so it can be the a or the b. It's up to you. We don't know the other leg, but we know the hypotenuse is 89. All right, so I'm going to grab a calculator here, and I'm going to go 39 squared and 89 squared. Now to get b squared by itself, I need to subtract this to the opposite side. So b squared equals 6,400, and a lot of students want to put in the past 6,400 here. Remember, we have to isolate the b by taking the square root. So we have the square root of 64, and we end up with 80. Thank you. So this missing side here is 80. Okay, now there's 3 things, only sine, cosine, and tangent. Only 3. Before I get started, because you can do this at the beginning or at the end, in quadrant 3, what's the only thing that's positive? Tangent. So tangent's positive. I know the others are going to be negative. All right, here we go. Sine, okay, I got to think. Sine is opposite over hypotenuse. So from here, opposite is 80. Hypotenuse is 89. All right. I already can see the cosine. Well, the cosine's already given to me. 39 over 89. Now tangent. Tangent is opposite over adjacent. Opposite here is 80. Adjacent is 39. We are done with example number 2. Look at example number 3. So the first thing we're going to do is our goal is to determine which quadrant, 1, 2, 3, or 4, will have the double shading. So let's look at what the facts that they give us. I can see that I have a tangent value that is negative. So underneath this, I'm going to write negative. I don't care what the number is, I can see it's a negative value. And this says the cosine of the angle is less than 0. Less than 0 also means negative. So I'm going to write down all star trig class. And then I'm going to come over here and I'm going to shade in true statements. Okay, where are tangent values negative? Well, all things are positive here and tangents are positive in here. I don't want positive, I want negative. That means tangents must be negative in quadrants 2 and in quadrant 4 because they're positive in 1 and 3. Where are cosine values negative? Well, cosine values are positive in 1 and positive in 4, but I'm not looking for positives, I'm looking for negatives. So I'm going to shade in 2 and in 3. And only one quadrant will have that overlap or double shading. In this case, it's quadrant 2. So I'm going to choose a point somewhere in the middle. I'm going to go back to the origin, straight down to the x-axis, and this is my angle that I'm going to evaluate. This is the terminal angle. Okay, so next up we want to remind ourselves, what does it mean to be at the tangent? So I can see that tangent is opposite over adjacent. So I'm going to remind myself, this is opposite over adjacent. Also, because I know a lot of students struggle with identifying the sides of the triangles, the diagonal is always the hypotenuse. The side that runs along the x-axis is always adjacent, and then opposite of the angle we can see is right here. Okay, so the tangent is 15 over 8. So I'm going to go opposite, I'm going to write a 15. Okay, opposite is here, that's a 15. And adjacent is an 8. I need to figure out now what is the hypotenuse. A squared plus B squared equals C squared. This part is also confusing students, like which one gets the A, which one gets the 8. These are both legs. They create the 90-degree angle, so therefore the A and B, it doesn't matter which one goes in for A or which one goes in for B. Now I'm going to be a little lazy right now. I wrote that down, but I'm going to grab the calculator and you can do the same. We're going to go 15 squared plus 8 squared, and we can see we get a 289. So this is 289 equals C squared, but I need to isolate the C by taking the square root. Square root of 289, and that produces a 17. This is 17. Okay, so we've got that down. Let's go ahead. We got 3 primary trig functions: sine, cosine, and tangent. Keep in mind that in quadrant 2, only the sign is positive. So positive, negative, negative. Now we're going to create those ratios, but we already know one of them is negative 15 over 8. By the way, a lot of students are going to say, Miss Bradley, when you put the 15 and the 8, why did you not include the negative sign? That just tells us which quadrants to shade. Remember, these are lengths of a triangle, and lengths are always positive. All right, here we go. So sine of this, sine is opposite over hypotenuse, 15 over 17. Cosine is adjacent over hypotenuse, 8 over 17. Let's talk together. I'm going to start explaining in this video how we can choose which quadrant. That's our first step. So I'm going to remind myself of all star trig class. This tells me what things are positive. Okay, so what's the fact that we know? We can see we have a tangent that's negative. So I'm going to write negative here. And we have a cosine value that's less than 0, which means it's also negative. Okay, so I'm going to make my chart and I'm going to do my shading. Where are tangent values negative? Well, all things are positive here, and tangents are positive here, but I don't want to know where they're positive, I want to know where they're negative. So it must be in the other two quadrants. Next, where are the cosines negative? Well, all things are positive in 1, and cosines are positive in 4, but I want to know where they're negative. So if this is where they're positive, the other two will be where they're negative. And we see shading in quadrant number 3. So please go up, follow along with me, go somewhere in that middle, and we're going to graph this terminal angle going back to the origin and then straight down. Closest to the origin will be the angle that we're going to evaluate. Next up, we have to know, what does tangent even mean? Tangent is opposite over adjacent. So opposite over adjacent. I'm also going to come over to my triangle. Remember, the diagonal is always the hypotenuse. The side of the triangle that aligns with the x-axis is always the adjacent, and then across will be the opposite. So here we go. Opposite is going to have a length 12. So I find opposite, that is length 12. Adjacent is length 5. Okay, adjacent, here's adjacent, is length 5. So how do I find the missing side, which happens to be a hypotenuse? I have a squared plus b squared equals c squared. In this case, I also have 2 legs. The a can be the 12 or the 5. It doesn't matter which one it is. And I'm going to be a little bit lazy here. I'm going to grab that calculator. You can do the same if you're in front of me or if you're rewatching this. And we're going to go 5 squared plus 12 squared. And that's going to be 169. That's going to be the value on the left-hand side. This is not a length of 169. We need to take the square root of it. So all of the problems you're doing today, when you take that square root, it's going to be a nice, pretty whole number. So we have a length of 13. I'm going to come over. Remember, we're only doing the primary trig functions: sine, cosine, and tangent. Sine, cosine, and tangent. Now, in quadrant 2, only sines are positive. The other two get a negative. And I already know, if I zoom out here, I already know the tangent is negative 12 over 5. 2 left to do. What is sine? Well, sine means opposite over hypotenuse. So opposite is 12, hypotenuse is 13. Cosine means adjacent over hypotenuse. Okay, adjacent is 5, hypotenuse is 13. Why the last two may initially be a little confusing for students is up to this point, when I give you the 2 facts, they've always been sine, cosine, or tangent. So what we have to remember is cosecant. Which trig function is cosecant related to? Anybody remember? Sine. So let's write sine. And then you have to know, how are they related? Well, they're related, but they have the exact same sign. So if it's negative, or if it would have been positive, it would stay positive. And then they're just reciprocals. So I'm going to write 5 over 13. It's the exact same thing now. We're going to go back to doing exactly what we've done. Let's start with, we know all-star trig class. That's going to tell us where things are positive. Got it? And then we're going to go through here and we're going to go over the facts. We have a sine value that's negative. Okay, I've got a sine value that's negative. Tangent is less than 0. I have a tangent value that is also negative. I'm going to make my graph for shading. Where are sine values negative? Well, this tells me where they're positive. So positives for everything is in quadrant 1, and sines are also positive in quadrant 2. I want to know where they're negative, not positive, which would be quadrants 3 and 4. Next up, where are the tangents negative? Well, everything's positive here, and tangents are positive here, but I want to know, where are they negative? That would be quadrants 2 and quadrant 4, and we can see the overlap occurs in quadrant 4. So let's make our next Cartesian plane, our XY axis. Let's go out somewhere in quadrant 4, draw that dot, make the line from the origin out to the dot, and then back to the x-axis. Next problem, next part, I'm going to come back here to sine. What do we know about sine? Sine is a representation of a ratio of opposite over hypotenuse. Opposite over hypotenuse. Got it. Oh, that's the first thing. Now, let's go and let's name these. We know the diagonal is always the hypotenuse. The length that's adjacent to the x-axis is always going to be the adjacent side. I should have said, sorry. It aligns with the x-axis, the adjacent side, and this is opposite. So I know we have a length of 5 for the opposite. The hypotenuse is 13. If you were in class in front of me, or if you were rewatching this, we are now going to find this missing side. A squared plus B squared equals C squared. These are the two lengths that create this 90-degree angle. So I know one of them is 5. I do not know the other one. 5 squared is 25. 13 squared, I believe, is 196, but I better make sure about that. No, it's 169, I think. Let's check. 169. And now I'm going to subtract 25 from both sides. And we have b squared is equal to 144. When I take the square root, we see we get an answer of 12. I'm going to slow it down for those that are catching up, and this is 12. I'm going to slow it down for those that are catching up. This is quadrant 4. In quadrant 4, only the cosines are positive. Everything else is going to be negative. I can see I already have one of the three, which is negative 5 over 13. Okay, what is the cosine? Well, cosine means adjacent over hypotenuse. So from this angle, adjacent is 12, hypotenuse is 13. Tangent means opposite over adjacent. So opposite is 5, and adjacent is 12. Here's our very last one. And so when we see secant, we have to recognize that secant is the reciprocal of cosine. So we keep the same sign. If this was positive, this will also be positive, and I'm just going to take the reciprocal. All right, so I have a cosine value that's positive, and this means the tangent of the angle is also greater than 0 or positive. So let's figure out where we're going to shade. All-star trig class. Okay, where are cosines positive? Cosines are positive, all things are positive, and cosines are positive in 1 and 4. So I want to know where are they positive. I shade 1 and I shade 4. Where are the tangents positive? Tangents are positive in quadrant 1 and quadrant 3. And we can see the overlap occurs in quadrant 1. Closest to the origin will be the angle we're going to evaluate. And I'm going to go ahead and just remind ourselves, hypotenuse is always the diagonal. The length of the triangle that aligns with the x-axis is your adjacent, and then opposite is straight across. All right, what do we know? Well, we know that cosine is adjacent over hypotenuse. So I'm going to come up here and remind myself adjacent over hypotenuse. Okay, so adjacent here is this length, it is 12. Hypotenuse is this length, it is 13. And I would do a squared plus b squared equals c squared. So I only know one of the two legs. The 12 can go in for a or for b. 144 plus b squared equals 169. When I subtract here, I end up with 25. And the square root of 25 is 5. So I'm going to come off to the side where you have room to see. I have sine, cosine, and tangent. Now in quadrant 1, all things are positive. All things are positive. So each one of these is positive. I already know the cosine is 12 over 13. Sine, well, what does sine mean? As a reminder, sine is opposite over hypotenuse. Okay, opposite is 5, hypotenuse is 13. Tangent is opposite over adjacent. Okay, opposite over adjacent, so 5 over 12.